Welcome to our channel. Hello everyone. This video is about periodic table and its classification. If you like this video, please like, share and subscribe. Without delay, let's get started. Periodic table part 1. Periodic table is divided into 4 blocks: S block, P block, D block and F block. S block elements. S block elements are again classified into two types: alkali metals, alkaline earth metals, which is also group 1 and group 2. General electronic configuration of alkali metals is Ns1. General electronic configuration of alkaline earth metals is Ns2. Sodium electronic configuration is 1s1, 2s2, 2p6, 3s1. Magnesium, it is alkaline earth metal, 1s2, 2s2, 2p6, 3s2 electronic configuration. General characteristic of S block elements: low melting point and boiling points, strong reducing agent, low ionization enthalpies, highly electropositive, impart characteristic color to the flame. Except beryllium and magnesium, because beryllium and magnesium are white in color. Valence electrons. What does mean of impart characteristic color to the flame means? If energy is applied to the any an atom, the the valence electron is excited from lower energy to higher energy. After some time, electron de-excited from higher energy to low energy. When this happens, energy is emitted whose wavelengths are corresponds to visible region. Therefore, alkali metals impart color to the flame. Coming to P block elements. P block elements are present in right part of the periodic table. These constitute the groups 30A to 7A and 0 groups are group 13 to 18 group 18 of the periodic table. Most of the P block elements are metalloids, non-metals, but some of them are metals also. The last electron fills in F block F orbital of valence shell. That is why it is called P block elements. 13 group boron family. Electronic configuration of boron family is Ns2, Np1. Aluminium atomic number is 13. 1s2, 2s2, 2p6, 3s2, 3p1. 14th group carbon family. General electronic configuration of 14th group is Ns2, Np2. Silicon atomic number is 14, and 1s2, 2s2, 2p6, 3s2, 3p2. The outer shell configuration is 3s2, 3p2. That's why we write an ns2, np2. 15th group nitrogen family, ns2, np3, nicogen. Nico means fertilizers, gen means produce. 13th group boron family. General electronic configuration is ns2, np1. Aluminium 1s2, 2s2, 2p6, 3s2, 3p1. 14th group carbon family, ns2, np2. Silicon atomic number is 14. 1s2, 2s2, 2p6, 3s2, 3p2. 15th group nitrogen family, ns2, np3. Nicogen. Nico means fertilizer, gen means produce. Phosphorus atomic number is 15. 1s2, 2s2, 2p6, 3s2, 2p3. Outer cell configuration is 3s2, 3p3. That's why we taken general configuration of 15th group is ns2, np3. Boron family, third A group or 13th group. Carbon family, 4th A or 14th group. Nitrogen family, 5th A or 15th group. Oxygen family, 6th A or 16th group. Halogens family, 7th A or 17th group. Inert gases family, 8th A or 18th group or 0 group. Why alkali metals and halogens are so reactive? If take all inert gases, outer electrons are 2. For neon 28, argon 288, for krypton 2818 8, for xenon 2818 18 8, radon 2818 32 18 8. These noble gases are comparison with alkali metals like lithium and sodium. If take outer electrons of lithium 2 1, for sodium 281 1. If lose one electron, it attains inert gas configuration. If take examples of halogens, like fluorine, atomic number is 9, outer cell configuration, outer cell electrons is 287, 287. One electron less to inert gas configuration. If gains one electron, it attains inert gas configuration. Therefore, alkali metals and halogens are more reactive due to easily they attain noble gas configuration. 16th group, oxygen family, chalcogen. The electronic configuration is NH2 NP4. Chalco means ore, gen means produce. Uh, Sulfur, atomic number is 16, 1s2, 2s2, 2p6, 3s2, 3p4. Outer cell electronic configuration is 3s2, 3p4. That's why we took outer cell configuration is NH2 NP4. 17th group, halogen family, NH2 NP5. Halo means salt, gen means produce. Chlorine and its atomic number is 17. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6. Sorry, 3p5. 18th group, zero group, inert gas or noble gas and rare gases. The outer cell configuration is NH2 NP6. Argon and its atomic number is 18, 1s2, 2s2, 2p6, 3s2, 3p6. All inert gases are has electronic configuration is NH2 NP6, but helium shows the electronic configuration is 1s2. D block elements. D block elements also known as transition elements because a majority of these metals will have more than one charge. They can transition from one state to another state in terms of charge. D block elements are again classified into 3D, 4D, 5D and 6D. These are the present in the middle part of the periodic table. These constitutes third B to 7B, 1B and 2B are also 3 to 12 groups of the periodic table. Filling of the electrons in penultimate shell n minus 1 d cell. 3D series. 3D series also known as first transition series having 10 elements starting from scandium atomic number 21 to atomic number 30. 30 atomic 30 is zinc. 4D series. 4D series also known as second transition elements having 10 elements starting from yttrium to cadmium. 5D series. 5D series also known as third transition elements having 10 elements starting from lanthanum to mercury. Example arum, xenon, 5D10, 6s1. Why we take xenon here? Because nearest noble gas configuration is xenon. Xenon atomic number is 54, 54, 64, 64 and 65. One is okay. 6D series also known as fourth transition elements having 10 elements starting from actinium to copernicium. Example rutherfordium. Radon 6D to 7s2. Radon electronic atomic number is 18, 6D to 7s2. Questions which are related to electronic configuration of elements, S block, P block, D block and F block. If take S block elements, group 1 electronic configuration is NS1, group 2 electronic configuration is NS2. Therefore, if we combine nth cell s orbital, 1 to 2 electrons are present. For p block elements are those elements which valence electrons in p orbital. Nth cell s orbital 2 electrons, nth cell p orbital 1 to 6 or 6 electrons are present. Electronic configuration of D block elements, n minus d cell means penultimate cell d orbital 1 to 10 electrons, n cell s orbital 1 to 2 electrons are present. For F block elements, n minus 2 cell F orbital 1 to 14 electrons, n minus 1 cell d orbital 0 to 1 electrons are present. Nth cell s electron, nth shell s orbital 2 electrons are present. Coming to f block elements, f block elements are classified into two: lanthanides and actinides. All F block elements are metals. They are paramagnetic in nature. They form colored compounds, easily tendency to form complexes. Filling of electrons takes place in antipenultimate shell. Chemically, lanthanides are very similar, so it's very difficult to separate from mixture. By application of chemical property, we can separate. Similarly, actinides also have similar chemical properties. The number of actinides show phenomena of radioactivity. Lanthanides starting from atomic number 58 to 71. Lanthanides belongs to third group and sixth period, having n minus 2 f orbital 1 to 14 electrons, n minus 1 shell, d0 d orbital 0 to 1, ns2 electronic configuration. This is anti-penultimate shell, this is penultimate shell, this is nth shell. Lanthanides are third B group and sixth period. The lanthanide starts from 57 to 71. We may get one doubt why they didn't put 58, 59, 60. Why? Because of if they put here, the overall period table would have disturbed. That's why they they separately put under the periodic table lanthanides and actinides. Actinides, which belongs to third B group and seventh period. And general electronic configuration of actinides: n minus 1 shell, f orbital 0 to 14 electrons are present, n minus 1 penultimate shell, d orbital 0 to 1 0 to 1 electrons are present, n orbital, s shell 2 electrons are present. Hydrogen and helium are exception to a block classification, because helium, the electronic configuration is 1s2. Why? Actually what we discussed before, the electrons, the last valence electron enters into the s block, which is called s block elements. The valence electrons enters into the p block, that's called p block elements. Like that we discussed, right? But here the valence electrons enters into the s block, but why they put in p block elements? Why? Because of they are related to inert gas properties. That's why they put in p block elements. Hydrogen also, the hydrogen electronic configuration is 1s1. The last electron enters into the s cell. Number of valence electrons is 1. Either it can lose one electron like this. If gain one electron, H minus. Hydrogen similar to alkali metals and also similar to halogens. Alkali metals, the electronic configuration is ns2. Sorry. The alkali metals electronic configuration is ns1. If take lithium atomic number is 3, ns2 np. Lithium atomic number is 3, outer electrons are 2, 1. If lose one electron, it gains noble gas configuration. And if you take examples for halogens, see fluorine 2, 7 are outer electrons. If gains one electron, it attains noble gas configuration. Likewise, hydrogen also 1 electron less to noble gas configuration. If gain one electron, it attains noble gas configuration. That's why it's similar to halogens and alkali metals. Therefore, similarly, hydrogen gains one electron, stabilize itself. That is to complete duplet structure. Atoms follow duplet rule or octet rule. Every atom wants to become stable. To attain stability, either share, lose, or gain electrons. to complete the valence shell electrons and get noble gas configuration. To get stabilize, they follow duplet rule or octet rule. That's all for today. Thank you for watching.